In this final section of chapter 3, we're going to look at solving inequalities involving quadratic functions. Now, there's some tried and true methods for solving these, and they all start out by getting everything onto one side. So for example, if we want to solve the inequality negative x squared plus 8 is greater than 2x, we're just going to move everything over to one side. I'm a big fan of having a positive number in front of the x squared, so I'll take these two terms and move it to the other side by adding and subtracting appropriately. So we get 0 is greater than x squared plus 2x minus 8. Now, this is an okay statement. What we're going to do is take it one step further and factor this. So setting that up, we know that we need the terms that multiply to be negative, which means one has to be positive, the other has to be negative. And we need that the larger of the two numbers that we come up with has to go with the plus because this is a plus here. So thinking of the numbers that make up 8, you can use 1 and 8 or 4 and 2 or some other combination of fractions. But for this purpose, we need two numbers that are 2 units apart that multiply to 8. And that's going to be 4 and 2. Now, the reason why we want to rewrite this as a multiplication instead of as an addition and subtraction comes from this property here. So if I told you that you have two numbers or two expressions, a and b, and they add up to 0, the best we can get out of this statement is that a is equal to negative b. And that's pretty good, but it recursively defines one thing in terms of another. It doesn't give us a definitive answer for what a is, except that a is the negative of b. But if I told you that a times b was equal to 0, then we know a lot more information. We know that either a is equal to 0 or b is equal to 0. This is the property we want. We can now say that this expression or this number a is 0 or b is 0. Going back to this example, if you start plugging in different x's, you're going to have multiple things changing around. But over here, since it's now multiplication, you have a nice process of figuring out where this is equal to 0. So that's going to be our first step after moving everything over. So determine where x squared plus 2x minus 8 is equal to 0. Since we have it factored, we have x plus 4 times x minus 2 is equal to 0. And so we have two things that multiply to 0, meaning that one of these two has to equal 0. Solving that, you get x is equal to negative 4 or x is equal to positive 2. Now, using that, we know because when x is equal to negative 4 or 2, we get 0. We know that for x not equal to negative 4 or 2, this x squared plus 2x minus 8 is not equal to 0, which means that it's either positive or negative. And so we're going to do a couple different methods to solve this. Method 1, we're going to create a number line. We're going to put down the number negative 4, put down the number positive 2, and then we're just going to pick out a couple sample points from the corresponding intervals that we're looking at. So this is from negative infinity to negative 4. This is from negative 4 to 2, and this is 2 to infinity. Pick your favorite number that's less than negative 4. I'm a big fan of negative 5. Favorite number between negative 4 and 2, always go with the 0. And favorite number that is larger than 2, let's say 3. And what we'll do is plug each of these numbers into the quadratic function and take note of the sign it produces. So we have -5 squared plus 2 times -5 minus 8, which gives us 25 minus 10 minus 8 for a grand total of +7. I don't care that it's 7, all I care about is it's positive here, so I'm going to keep track of that with a positive sign. When you plug in 0, you get 0 squared plus 2 times 0 minus 8. Really quick calculation, you get -8. The 8 doesn't matter, the negative does. So we get a negative here. And then when we plug in 3, we get 3 squared plus 2 times 3 minus 8. So that's 9 plus 6 minus 8. 15 minus 8 gives us 7. Again, the positive fact is the one that we want. So we now have enough information to solve this question over here. We want all x values that make x squared plus 2x minus 8 to be a negative number, right? Because if 0 is larger than that, that means that this has to be negative. We come down to this number line, and this interval right here is going to be our answer. Let's look at a second method of solving this, which this method is really good when we get into polynomials because it works with more things than just multiplying 2 binomials. It'll work with multiplying 5 binomials. And it starts off very similar to what we did here with the number line. We're going to take the intervals for which we know that this quadratic is not 0, and we're going to arrange it into a chart. And from our factored version, we know that we have a x plus 4 and an x minus 2. And then when you multiply these together, we end up getting x plus 4 times x minus 2. So again, pick your favorite number that's less than -4, which gives us -5. Favorite number between -4 and 2, let's say 0. And favorite number larger than 2, which gives us, 3. And again, you're going to take -5 and see what happens when you add 4 to it. That gives us -1. And so that result is negative. If you take -5 and subtract 2 from it, you get -7, which is a negative number. And when you take a negative times a negative, you end up getting a positive. So this plus right here corresponds to this plus right here. If we were to take 0 and add 4 to it, we get a positive. If we take 0 and subtract 2 from it, we get a negative number. So a positive times a negative is negative. And if we do 3 plus 4, it gives us 7, which is positive. 3 minus 2 is 1, which is also positive. So positive times positive gives us positive. And notice that this column here matches up perfectly with those plus minus symbols there. And again, we want all the x values that cause this expression to be negative. So right here is the one that we want. And again, our answer is going to be the interval from -4 to +2. We don't include -4 because that causes the function to zero out, and we want a strict inequality. Same thing with 2. That's why we have the parentheses instead of square brackets. For this second example, we're going to do something very similar, but we can try out a third method or a third way of examining this problem. We're going to get everything onto the same side, and again, I like having x squared be positive. So I'm going to move the other side over by adding 3x and subtracting 28. Now we're going to factor. Since this is a negative, we know that we have 1 plus and 1 minus. Since this is positive, we know that the larger number goes with the plus and the smaller number goes with the negative. And we need two numbers that multiply to 28. If we list those out, we have 1 and 28. We have 4 and 7. We also have 2 and 14. And those are the nice ones for the time being. Now this 3 indicates that we need a combination of numbers that are only 3 units apart. 1 and 28 are 27 units apart, 2 and 14 are 12 units apart, 4 and 7 are only 3 units apart. So this is the one that we want to make up this 3. And since the plus is here, that means that the 7 has to go with the plus down there. And a 4. So again, once we have it factored, we solve for where this equals 0. So that's x is equal to negative 7, and x is equal to positive 4, to make x plus 7 times x minus 4 equal to 0. Now, you can do method 1, or you can do method 2. Or, since we know how to graph these quadratics, we can talk about what's going on. It's a parabola. And so, we know that its general shape is either a frowny face or a smiley face. Since the leading term is 1, which is positive, we know that our graph, or our parabola, looks like this. And since we know it looks like that, and we know that it zeroes out at negative 7 and at positive 4, that's where it crosses the x-axis. We know that it's negative here, positive here, and positive here, because if you were to sketch a graph on top of this of the parabola, it would have to look like this. And notice that the positive is because this is above the x-axis, the negative is because this is below the x-axis. So this is what I would consider method 3, is a graphical method. Now that we have that information of a plus minus plus, we need to make sure that this symbol works. So we have x plus 7 times x minus 4 has to be greater than or equal to 0, which means we're looking for where the pluses are. So greater than or equal to 0 means looking for a plus. So the first interval we have is negative infinity to negative 7, and also 4 to infinity. Because this has the greater than or equal to, we can take the values that cause this to equal 0 as good ones. So we're going to use square brackets for both of those. And then since these two sets, or these two intervals, are separated by a little bit of distance, we need to take the union of that. And you can double check your work. Take a number that is in here. Let's say negative 8. If we worked with the original inequality, we would have negative 8 squared, which gives us 64. And what I like to do is create a blank box, which we'll fill in with the inequality that fits it. And on this side, we're going to do negative 3 times negative 8 plus 28. All right, negative 3 times negative 8 gives us 24. 24 plus 28 is going to give us 52. Neat. So 64 is strictly greater than, and technically greater than or equal to 52. So this is a good value, which means that this is a good interval. You can do the same thing over here by picking, say, 5. If we plug it into the original, we have 5 squared, which gives us 25. Compare that to negative 3 times 5 plus 28. Negative 3 times 5 gives us negative 15. And if you add that to 28, that gives you 13. So 25 is greater than or equal to 13. So this is a good value, making that a good interval. Now, if you pick something that's not in this interval, let's say you chose 0, right? We would have 0 squared, which gives us 0, compared to 3, or negative 3 times 0 plus 28, which gives us 28. And so that is the wrong symbol for this inequality, which means this right here is our answer.